The first known telescope design came from the mind of the German-Dutch spectacle maker Hans Lippershey, who tried to obtain a patent for it in 1608. A year later, the famed astronomer and mathematician Galileo Galilei built on this design to build his own device. Galileo's was a refracting telescope, using a lens to collect light and form an image. Since then, many more have contributed to advancing the telescope's capabilities. Sir Isaac Newton develops the first reflecting telescope in the 17th century, using a smooth, curved mirror instead of a lens to collect the light. Newton's version, especially, has become standard in astronomical research. In modern times, we've built larger and larger telescopes to increase power and see further out into space. But this approach has its limits. The next key step was to deploy telescopes actually in space, meaning they'd be free from atmospheric interference. By far the most famous, until recently, has been the Hubble Space Telescope, launched in 1990. Over the decades, it's returned some incredible images, allowing us to peer deeper and deeper into the cosmos. However, while Hubble is still operational, its even more powerful successor was launched in December 2021, the James Webb Space Telescope. Webb is both the largest and most powerful space telescope ever built, with a gold-plated primary mirror that's 6.5 meters in diameter. Its cameras and spectrographs allow it to observe the universe in a lower frequency range than Hubble does, and the gold plating on the mirror is there to provide infrared reflectivity. A micro-shutter mechanism allows Webb to image over 100 objects simultaneously, while the telescope also includes a sun shield the size of a tennis court to keep everything cool enough for the equipment to properly function. The mirror and sun shield are so large, in fact, that they had to be folded for launch. It was only once in space that they were unfolded, in a complex procedure that took days. Webb is now fully operational and produces the clearest images of the universe that scientists have ever seen. However, future telescopes are already being planned to accomplish what Webb still cannot. Probably the most anticipated next telescope of all is the Nancy Grace Roman Space Telescope, named after NASA's first female executive who earns the nickname the Mother of Hubble. It had originally been named simply the Wide Field Infrared Survey Telescope, and it's currently under construction, expected to launch sometime in 2027. While comparable to Webb in some aspects, the Roman will have some different capabilities and goals. While Webb takes high-definition images in a very narrow range, Roman will have a wider field of view, which will allow it to take massive, sweeping pictures of the cosmos, although at the cost of some resolution. As such, the Roman will capture much larger images of the universe and will be better able to look into some of the deepest mysteries in astronomy, such as the nature of dark matter and dark energy. And a breakthrough here would mark one of the greatest scientific discoveries in recent history. Roman will be equipped with a coronagraphic instrument to directly image and characterize exoplanets. This could then lay the groundwork for future observatories to take even clearer images of Earth-like exoplanets in other star systems, an essential step in looking for other locations that could potentially harbor life. The Hubble Space Telescope was designed with a similar functionality in mind, and its photos definitely transformed astronomy, and really, they'll continue to do so. Even with Webb and eventually Roman in the skies, Hubble won't be redundant. It will still be the only telescope designed to take images in the ultraviolet spectrum, and so it will work alongside all other observatories to continue cataloging the universe. But again, the Roman will dwarf its ability to see the cosmos at large. It could be capable of capturing views up to 300 times more massive than Hubble can, and many times wider than Webb, offering researchers a look at entire galactic ecosystems. For context, after only 5 years of its mission, It's projected that Roman will have covered an area of the sky some 50 times wider than the Hubble has managed in its 30-year lifetime so far. Meanwhile, since the Webb is built for narrow imaging, even it can't compete with Roman when it comes to this super mapping task. With the launch of Roman in around 5 years' time, NASA will bring in a new era for space exploration. It'll produce glittering panoramas of the cosmos, allowing astronomers to obtain greater background information for thousands, millions, perhaps even billions of stars. Roman will study the base environmental factors behind why certain stars differ from others, and will render the jigsaw puzzle of the universe in all new detail. Really though, what's truly exciting is just what might be achieved when all three, Hubble, Webb, and Roman, combine. Together, these telescopes will study an endless stream of objects from 3 different viewpoints and multiple different wavelengths. The scientists, space agencies, and organizations that get to pore over their data will have more of the universe to appreciate than any generation before. Ultimately, Webb is still set to continue as the largest and most powerful space telescope ever constructed. But Roman looks at things in an alternative way and will certainly capture the widest views possible, while Hubble will bridge between the two, the seasoned standard-bearer for all things modern astronomy. As for what comes next, it's difficult to say, but even near-future technologies have the potential to eclipse both Webb and Roman before long. It could be that advancements in methodology plus new ways of exploiting technology will lead to entirely novel ways of imaging the universe over the next few decades. For example, one proposed method of improving a telescope's power of sight is to develop a solar gravitational lens. Stanford astrophysicist Alexander Madurowicz and Bruce McIntosh have proposed a new breed of telescope that will be able to view objects behind the sun in extreme detail, thanks to the magnifying effect that the sun's gravity has on the light traveling through it. This technique might even allow us to see astronomical objects up to 1,000 times more clearly than anything we currently have. But it's a technology that's still some way off, as it depends on our first achieving advanced forms of space travel to position such a telescope to begin with. Finally, though there's also the Giant Magellan Telescope, or GMT, to consider too, construction for which has already started. This observatory in Chile, which could be operational by 2029, will reportedly have 4 times the resolution of Webb, will be the largest telescope on Earth, and will be up to 200 times more powerful than any other Earth observatory to date. The GMT will further look for exoplanets, among other things, but astronomers are especially excited about its potential accuracy. If it hits expectation, then it'll be capable of making out finer details from fainter light sources than Webb can now, or Roman will soon. It's been said that humanity is entering a new golden age for telescopes and astronomy, where more parts of the universe will be more visible than ever before. It's predicted that many new discoveries will be made imminently, and our understanding as a species will rapidly grow. But what's your verdict? Have you found the first images released by Webb? What do you hope will be in the pipeline for Roman? And where do you see this field of study going in the next 10, 50, or 100 years? It's an exciting road ahead, beginning with the very next step along it. And that's why NASA's next telescope will be even better than the James Webb.